Good morning. Welcome to today's webinar. We're going to talk about photogrammetry and drones. We have the presence of Carlos Zuluaga, a civil engineer with a passion for construction. After having experience in most life cycle phases of a construction project, from bidding to handling a project's warranty phase, he's focused on the topic of construction safety. And Dr. Will Iker, PE, PhD, is Director of Research and Education at Beamform Global. Dr. Iker will be moderating today. Welcome. So thank you, Carol, for being here with us. So tell us more about you. How did you start in this with drones in Beam?
Thank you.
Some about your
Thank you
background.
for having me here. So my journey really with Beam drones and general construction technology started when I was in grad school doing my PhD. You're very fortunate in that environment in that you can just approach anybody, go to the library and research different things. There's maker spaces. And I was extremely interested in just learning about all these applications. So I started learning about 3D printing, wearables as part of my research in construction safety. um, I had some prior knowledge in GIS, and that took me to drones. And then, kind of that natural process of involving technology in the industry also led me to Beam, which is something that I practice now in my current company, Harkins.
Okay, that's great. So you're gonna share with us some of your projects.
Yeah, I'll talk about a few of those in there with drones. And how we really put everything together.
Mhm.
All this information to have like that digital twin to just really help us be more efficient and communicate more efficiently, because the I think 90% of the problems that we have in construction is because we don't understand each other, is communication.
Okay.
So these are all tools to help us communicate more clearly.
So how do you think drones are revolutionizing the Beam life cycle in construction?
In many ways, it's just democratizing the information. So think about, at the onset of a project, you have a green field and you're trying to obtain information about, elevation conditions, a digital elevation model. And, you used to have a surveyor do it. It would be a very laborious process. Uh,
Hmm.
when you have a very vegetated area, it would be very difficult to access. So right now with drones, that is just making it that much more easier than it was. And then now during construction, which is really that phase that I've been very familiar with, it allows us within an hour or two to have a huge amount of information for volumes, for elevations, for the current status of a project. It allows to have all of that information rather quickly, as well as having a very good historical record in case something happens and we have to rely on that information. So it really helps out
Hmm.
everybody, all of the stakeholders, design teams, the developers and the owners, as well as in the general contractors side.
Yeah, thank you. So I'll let you start with your presentation. Go ahead. The stage is
Awesome.
yours.
All right, let me share that screen.
Yeah.
Sounds good. Let me know if you see it.
Yeah, we can see it.
Awesome. So I'm going to talk a little bit about drones in construction. I know there's a lot of applications for research, for the land development side, but I'll talk about how we use it in construction. So very quickly, I think I've talked about who I am, Carlos Zuluaga. I have a PhD in civil engineering from North Carolina State University, and I work for Harkins Builders. The bread and butter of our company is wood frame construction, 4 to 5 stories, with one or two podium decks. We are based in Columbia, Maryland, but we also have offices in near Philadelphia, Charlotte, Raleigh, and most recently one in Richmond, Virginia. So a lot of growth. We're very happy, and we're very proud to say it's 100% employee owned. So all of these things that we do are really for our benefit. Makes me very passionate about what I do. Just entering what drones are. In essence, they are a craft without a human pilot or passengers. I think most people relate drones to simply, the quadcopters that you see, but they can be underwater. They're most commonly referred as ROVs, or remote operated vehicles. They can also be on top of the water. You see that sail drone, that's the second image. They go and navigate on their own. I hope a lot of you have had the opportunity to see Spud, the dog created by Boston Dynamics, which on top of that has a LiDAR scanner. It's a thing of beauty, and technically that's a drone. You can program it to go around the job site and perform a mission. And of course, the ones that we will be focusing today, which are aerial drones like the octocopter that you see on the right-hand side. Drones are also referred more technically as UAS or UAV, unmanned aerial or aircraft systems or vehicles. There's generally three types of aerial drones: quadcopters, which are the most common you'll see out there. They're very, very user-friendly. They'll hover if there's any problem. They have multiple sensors for safety. There's fixed-wing drones as well, far, far trickier to fly. I've had the opportunity to fly one and crash it as well. Landing, you need a runway for it. So that was one interesting, use of it, or difficulty for it. And then we have more advanced drones, VTOL, vertical takeoff and landing. So they take off vertically as your quadcopter does, but then they will fly horizontally, and that increases so much more the efficiency and the time that they can be on the sky. One thing that I want to highlight to everybody, I don't know if many of you have your hobby drones, but because we're doing this for a commercial operation, first of all, you need to have your FAA Part 107 license. There are some exceptions if you already have an actual airplane license or helicopter license. And you also need to register your drones with the FAA. And more recently, something that is going to be starting enforced in April is that remote ID. You have to have some drones that comply with remote ID. That's something that's been talked about for many years, and now it's going to become it's going to be enforced. I'm going to say that most of you are familiar with the beauty of having that perspective from the air, right? Really nice pictures. It really allows you to see the job site from a different eye. And I think it leads to, of course, amazing marketing material, but it also allows to think differently. Of course, videos are another of that low-hanging fruit. Everybody likes to showcase the beauty of the job site with a blue sky on the background. So, that's one of those things that you can easily do with some of those drones, right? This is one of those projects that we're almost finished. Nice sunset is just a really, really good way of showcasing everything we do. But more than that, it offers the opportunity for having flight automation and therefore being able to have a lot of data recorded. So what you see here is that because I was a pilot on this specific job, I could fly every other day and start gathering documentation of the progress of this building. And as I mentioned, with flight automation, I could have the same view from different perspectives all the time. So very, very quickly, I'm telling you a story, and I'm having a lot of data through these pictures of the job sites, right? It just opens the door for a very, very good communication with all of the stakeholders. Now, one of the things I mentioned here are items that are done with regular, with drones that have a regular camera, like the ones you all know about. But there's also drones that can carry LiDAR. So the processes of obtaining information are a little bit different, the cost, and let me get a little bit into it. The way that photogrammetry works, it's going to be in a process called structure from motion. And then LiDAR stands for light detection and ranging. And these are two technologies to obtain different information from the ground using drones that'll achieve a little bit of different results. So photogrammetry, it's basically stitching pictures together to create a virtual representation. We can have an aerial view, which I'll show you a few examples later on, and a 3D model as well. LiDAR, on the other hand, uses pulse lasers or light, and then it measured the distance between the return of the light. LiDAR is generally faster for data collection. It is also more detailed, and it can cover more area in a single pass. But as we'll see in a minute, it is also more intricate. So photogrammetry allows you to have a 3D model and a 3D representation. It's data that is more relatable. You can look at it and immediately see, like on the left, that we're looking at a building, the street, but it also has some limitations in terms of the detail. So I specifically chose this picture because on the left, I actually had a scaffold there, but the drone was unable to figure out what was going on. It cannot get to that level of detail. On the other hand, you see in the picture on the right, LiDAR, that's a deliverable that you get. What is showing in the different colors is the elevation. But you can get to a level of detail that'll pick up the cables of transmission lines. And that's a huge asset when you need it, right? So it's something that it's quite important depending on your needs. One of the other advantages of LiDAR is a lot of the times it can capture ground data when you have heavy tree canopies, while photogrammetry will not be able to do that. Of course, all of this comes also to affordability. A very good drone for capturing pictures from the air, for doing photogrammetry. I think the standard right now is the DJI Mavic 3. Is going to cost you around $3,600, whereas a very basic drone with that can handle a LiDAR, and you also need a base station for it, is it's going to put you down $24,000. And this does not account for the difference in personnel and software required. So just to give you an example, I currently have an intern that has his FAA Part 107 license, and he can go to the job sites, fly the drone, upload the pictures to our software of choice, and provide a good deliverable to my job site. Compared to a LiDAR, I'm probably the only one in my organization that can do that information, that can process it. I need to have a really good computer. So, the cost of all of that also need to be taken into account. And just to kind of summarize what I just talked about, the difference between photogrammetry and LiDAR, I put together, this is kind of a relative chart of the different applications, right? Ideally, you want to have 100% of everything, right? Like this blue line covering all of those 6 items. But as you all know, with everything, it's hard to have it all in one piece of equipment. So because of the affordability, how easy it is to use, the type of deliverables we're looking at, as a company, we've chose to use photogrammetry for most of our processes in construction. However, there's a lot of folks also that use LiDAR out there. It's just that for our new buildings, which are most of what we do, really LiDAR has not provided enough value for us. So let me go in a little bit more into how we use it in construction. As I mentioned before, like the root of all of this is communication. This picture is very near and dear to my heart. Is kind of the first time that I brought an aerial image with an overlay to a trade partner meeting that we were doing every week, and we never went back. Like, I mean, all of my trade partners were asking for it, all of my clients, and it turned out to provide a huge amount of benefits. and to help the job site just perform better. So that image that I was showing there was processed through Drone Deploy. That has been our platform of choice. There's many other softwares that either can use advantage of cloud computing or can use your local machine. And in it, we start off basically with having a plan of what we want to fly, because of photogrammetry uses kind of stitching of images that have a certain overlap. You have to have a certain way of flying. So that's kind of what you see here, this rectangular pattern of flying. We also take advantage, not all the times, but many times, of ground control points. This is a way to ensure that the data is accurate. So it's a way to calibrate the model when you're trying to stitch all those pictures to ensure that they fit where they need to fit. And also some of them are used as checkpoints, which is kind of the way to verify that the model that you obtain is accurate. We do have some equipment, some enterprise level drones that also use advantage of RTK, which is real-time kinematics, just some better corrections for the GPS signals. But ground control points, really, it's what's going to give you the most advantage for having accurate data. So, after we fly the drone, really, this is almost automatic. After you're done all of the flight planning, you obtain this beautiful aerial picture, and you can start doing overlays just like that. Very easy. We can do additional items. So, for example, this grid you see here is something that one of our vice presidents kind of has as a standard for tracking, let's say, unsuitable site conditions. It's something that can be given to the people on the job site for acting on it right away. So, within a couple of hours, we can provide a deliverable that can be used in the field that has been very impactful. Just another example here, a project that we were about to start. We wanted to understand as a team exactly where that building was going to be. So because we have all of these georeference data, ground control points using, stakes that the surveyor provided us, we were able to clearly understand what was going to happen, how is the access going to be on our end. And just this picture alone allow us to start communicating with the client very early on the job for things that we thought could be problematic. So one thing right here at the bottom of the screen, and let me get a pen, is that we found out that this corner of the building was very close to our retaining wall. So way before construction started, we actually talked with the engineers and everybody and made a decision regarding the foundations. Another possibility of all of these data that we get, and using CAD files, we can do what I would call quality control from the air. So this is an example of a drone flight in which we use ground control points, and we obtain an accuracy. We can overlay CAD files within about an inch and a half accuracy. You can see in the screen how the walls align, and I can start understanding different things. So what I would do is I would print these reports for my teams, for the trade partners to start checking things, right? Like I noticed that some of those dock banks in there were going to have issues with the walls. We can also start looking at some of our stub ups before we pour concrete, and just help different people do things at the right time. This is actually an example of, one of those times in which I flew in an afternoon the day before we had to pour a few things, and I noticed that there was an inconsistency in what the drawing showed versus what was there in the field. We alerted the team, the concrete trade partner, and they immediately made corrections. So that was something that was really nice to see. Everybody missed it from the ground, but again, having a perspective from the air allow us to see that something was not correct. What drones allow you to also do is just to gather a lot of information. So this is a screenshot from Drone Deploy. Again, many items, many software can allow you to have these. This is a 3D model also of that job site at the time. And one of the beauties of this is that we can obtain information. So if I were to click in any of the pins, it'll give me location and elevation information. I just click in one of the lines and it gives me the length. I can get, the slope. I can get a surface profile. And also very impactful for us is the ability to obtain volume quantities rather quickly. I don't know how many people in the audience have been in construction trying to figure out the volume on a stockpile, and there's a lot of guesstimating out there. So we're taking that out of the equation. In this particular picture, we actually had a third party come and verify the stockpile, and we were within 1%, which was fantastic considering that some of those methods took a lot longer and there was a lot of cost involved in trying to get a surveyor on site compared to us flying the drone, and it took us about an hour and a half. This is another type of deliverable. We can obtain elevations, digital surface models. There's just a lot of flexibility in the information that we can obtain using the information from the drone. We also have a drone that has a thermal sensor. So it allows us to do surveys on site for, some of the quality, maybe an existing building in which we're trying to find a leak. And this is another of those applications that has been really, really game changing for our teams. And I think, one of those important considerations too is kind of having that digital twin. So this is a 3D model that was obtained from our drone flights. And then we can insert our BIM. And, right there, I'm going to walk you through my project. And that's going to take me about 30 seconds. You'll understand where I had my stockpile, what type of building am I doing, where is my tower crane. I have a theater on the east side. And, with just these few phrases, and by looking at this information, you already have a complete understanding of my job site, or at least a very good understanding of my job site. Whereas if I were using drawings or some sketches, it would take me a long time to explain all of these to you. And the last thing I'm going to show is actually a little experiment that we did with drones. We actually bought an FPV drone and we were trying to see how we could avoid going into a confined space. So you see there, we're testing our drone to go inside some an underground storm facility and trying to do some inspections. That way we don't have to bring somebody into a potentially dangerous environment that needed confined space certification. So quite challenging to fly inside. I made the mistake of opening 2 manholes, which created an amazingly difficult to fly air current. But, it's one of those applications of drones, right? To try to not put people in danger, because, losing equipment certainly is not as big of a deal as losing a life. Nobody wants that. So that's kind of our latest experiment with drones. We'll continue seeing what's out there, but that's how we've been using drones in construction.
Yes. So what do you think, what do you see in your construction is the biggest challenge you have had with drones?
Honestly, is getting more pilots, more people that just
Really?
want to get the certification. And at least as a company, it's the barrier to have a license and to tell people that they have to pass an exam on our
Mm-hmm.
end sometimes tells people back out, maybe they're too busy. But the power of having a drone on the job site is fantastic. And once that that license part is past someone, and there's no barriers. It's so easy. It's very intuitive to fly.
Yes.
Maybe in our geographical area, just because we're close to DC, not all of our job sites can have it. When you are
Mm-hmm.
near the 15-mile radius of DC, you have to ask for some special permits to be able to fly. It can be done. I've done it, but it's just, one more thing that you got to do.
Is it a different certification for each drone, or you can have the same one for all the type of drones?
Uh, so there's no certification for the drones per se. We do require internally, we have our own, standard guidelines that will certify people to fly different drones, just so we're comfortable that they know what they're doing and they understand the systems. But no, once you
Hmm.
have your FAA Part 107, it's up to each person to learn how to fly the drones. Most of them fly in the same way. We only use quadcopters. So it's very intuitive and all the controls are about the same.
Hmm. We have some questions for the audience. What are some good drone options for a company who are just starting out using them?
So I think the most basic drone that you can have if you want to do photogrammetry is going to be a DJI Air 2S. They actually just came out with the Air 3, but it still doesn't work for photogrammetry. That drone is going to set you back between 1,000 and 1,200. It is not expensive. However, the one I showed before, which is the DJI Mavic 3E, that's going to be your workhorse, and that's what most people use. But this is a $3,600 drone. Maybe that's going to be your second drone after you get your feet wet with that DJI Air 2S.
What would you say are the major benefits of implementing drones in construction?
I think, as I mentioned, like
Hmm.
communication is going to be number one. Um,
Okay.
as I was showing with this picture, this is a lot, right? I can bring this picture when I'm purchasing contracts with a trade partner. How are we going to attack? How are we going to do logistics? Um, and the other advantage is going to be documentation. As you know, documentation is, or for those of you that are in construction, is incredibly important for
Hmm.
schedules, for cost, certification. When you unfortunately have some arguments or some litigation, these pictures, these 3D models tell so much and provide a very, very accurate data instead of just relying on memory or just some guesstimating for like volume and stockpiles. So I would say, yeah, communication and efficient data collection are going to be kind of the two most
Efficient
important
data.
benefits.
Hmm. Yes. We have another question here. What drones are good for thermal and lidar?
So what is going to determine the drone is going to be the weight of the payload. When we talk about the payload, is that little, what you're carrying. So as far as thermal, for our uses, we've been using a DJI Mavic 2 Enterprise Advanced. That's the
Hmm.
one we had. That was around $11,000 at the time. However, there's a newer one, DJI Mavic 3E T.
Yes.
I don't have one, but it's going to be very good uh, for getting a sense of where everything is. I haven't done like a calibration study to know how accurate they are,
Hmm.
but I mean that's going to be within the affordable range of $10,000, $12,000.
Okay.
As far as LiDAR goes, the one I showed, that was a Mavic. Sorry, not a Mavic. That was the DJI M300 with L1 Zenmuse LiDAR. That is a 24,000. That's probably the cheapest I think you can have for LiDAR. But I gotta say, there's drones that are $20,000 and you can put on it at $150,000 LiDAR on it. So you're talking about and $180,000 piece of equipment, and it all depends on your needs. I personally, and as an organization, we don't have a need for an $180,000 piece of equipment because photogrammetry has covered all of our needs.
Hmm.
What, Carlos? Thank you so much for doing this. This is really great information. Um, have you done much calibration studies with photogrammetry, and what kind of tolerances are you finding from it?
So
And
yes,
how
we
has that
have.
changed over the years? Because I think, one thing with photogrammetry is it's all based on the number of photos, and the more photos you have, the tighter tolerances you can obtain. So, where do you see that today versus where maybe it's been 5 years ago, and where do you see it going maybe in the next couple of years?
So we've done studies with, and there's a lot of people that also have done. So some of our suppliers, E38 Survey Solutions, also has done it. So when I talked about ground control points, some of the ground control points that we put on the ground are used to calibrate the model. Think
Right.
about is you had a picture in a frame, right? You know the picture has to fit within the
Mm-hmm.
frame, and then some of those ground control points we use them to verify if point A that needed to be in coordinate 100, 100 is actually in that coordinate. Those are called checkpoints. So using those checkpoints, we've come up with accuracies of about an inch and a half horizontal, and about 2 inches vertically, which, when you think about an entire building that is 80 feet tall and you're measuring areas that are, 10, 20, 30 acres, that is fantastic. And it'll be much better than trying to walk around with the equipment. And the way we verify this is we have actually surveying equipment on site.
Right.
So it's really, really standing against that, right? Because it's also
Mm-hmm.
about a matter of time. So if you wanted, a surveyor could collect all of these data, but how many days is this going to take compared to us a few hours? And we are within an inch or two. So it's just fantastic. Now, LiDAR, um, talking about LiDAR accuracy, it's a little bit difficult because it depends on the number of points you collect, how much power you have in that sensor. But I think it's also very comparable to photogrammetry. As I mentioned before, is that LiDAR just gives you so much finer detail. I
Right.
cannot capture, transmission line cables with photogrammetry, but the LiDAR just gets them perfect.
Right. Because what about meshing softwares? What are you using? You should cut and fill volumes. What are
Mhm.
you using for post-processing applications?
So we're exclusively using drone deploy. The reason for that is that we are able to use their computational power. So everything is in the cloud. I'm not bogging down my own laptop for hours because this photogrammetry is very computational intensive. And it is also extremely user friendly for everybody in my organization, right? I have a few folks that are experienced, that have a good understanding of these systems and maybe settings and parameters with ground control points. Some don't. Some just want to fly, upload the pictures, and let it be. But then the user interface for the volume calculations, or for getting my slope, or just pulling out a picture, it's very, very good with drone deploy. So that has helped us kind of bridge a little bit of the different knowledge and experience gaps that we have amongst our pilots.
Oh, excellent. Okay. If you, what else is out there that you see other teams typically using if you're not using drone deploy
So
for?
Drone Deploy is a very good platform. Propeller Aero also has a great platform that they integrate also with some targets. I forgot the name of the points. It's probably called Propeller Points, and I apologize for not remembering the name. But it acts as those ground control points to give you really good accuracy. Pix4D is also a very, very good platform. Pix4D has products for both, I'm sorry, both your computer, so your personal laptop or your own server, and also in the cloud. There's Carl Sonagi Soft, but I think that's more used by people that use LiDAR or are really heavy into more of the surveying world.
Mm-hmm.
There's another one, but I'm blanking off. But again, I'm not in surveying. I need a platform that is very, very user friendly. So someone from an intern to a project manager to a vice president can get in and look at the information.
Very, very powerful. What kind of applications are you using here where you're mixing model and photogrammetry?
This application is called Revisto. So Revisto is our platform or choice for doing BIM coordination. And it allows you to import so many things. I can put in CAD files, obviously Revit, NWD, IFC files, which are all 3D. I can bring this mesh, which is that 3D model of the drone, but I can also import point clouds as well, either from ground devices, which we have a Matterport that has a LiDAR. We've used a Trimble X7, which is a laser scanner. We can bring all that information in there as well. So it's an amazing piece of software for data integration and visualization.
When you're putting together these projects, where is the most work on the back end? Is it bringing things into Revisto? Is it, it sounds like you're loading data into Drone Deploy and it's auto processing a lot of it. Is there a good bit of technician work there and just validating, or where do you see the amount of hours it takes on the back end after you've done the field data? Where's the most time?
It depends. So not all the time we fly. We want to like a really, really high accuracy, right? Some of our projects go out. They just want to get a project, like a progress shot of nice video, a little bit of pictures, and after we've done that, we do this flight that'll give them the orthophoto, just for like site logistics, job site coordination and documentation. But they're not so concerned if we are within 0.05% of the actual volume of the stockpile. They just want to get a general knowledge. So that'll be super easy. There's like almost no work other than sending a pilot and flying. If you want to get very accurate, then you start doing ground control points. Then you need somebody that knows how to process that data. So either you get your surveyor to put ground control points for you, or we send somebody that has we use a GNSS antenna, which is an RTK, which is we use MLEAD Reaches RS2s for the most part. We also have Trimble equipment. That'll step it up one notch, right? That person needs to be able to calibrate and understand GNSS equipment. And then after that, really you upload all the data to Drone Deploy on our end, and verification and validation of the data is very easy. You just select a few points on the screen, and is that what I expected? How far off is it? And it's very, very quick, very user friendly.
Okay. I guess where do you see this going? How many projects are you using photogrammetry on now? And is it all of your construction projects? Are there certain projects where, well, we think they're probably too small, we don't really need this? Or are you really just using it across the board on everything?
Yeah, I do not. So we have renovation projects that maybe you're renovating apartments inside a building. Like I don't have use for a drone there. The majority of our use is going to be in new buildings, or maybe if we're doing some renovations to the skin, or maybe in the roof, something like that. My dream really is that every job site has their dedicated pilot and their dedicated drone. The cost, I mean, it's very low when you're talking about $50, $60 million project. Even a $10 million project affording $2,000 or $3,000 drone is just peanuts compared to the benefits. But unfortunately, not everybody is motivated to get it. So we just have as far as our project controls, we go and fly like every month, most of the projects. But when you have a dedicated pilot, You fly anytime you want, whenever you need to. If you want to do it twice or three times a day, that's your choice. I mean, I've in fact have had benefited from this by helping the municipality. So we had an electric line, somebody hit it. We didn't know if the site was safe. We had the fire department on our job site, and I helped the firefighters understand if the job site was safe, so they were not put in danger. Even
Wow.
those little things were benefited just because I was a pilot and I had a drone on the job site. It's not something that if you don't, if I got to call somebody and schedule it to come, you cannot have that benefit.
What what's your view moving forward? Are these going to be project engineers that get cross-trained? Because some smaller jobs really might just have one project engineer for the entire project,
Yeah, and
staffed
that'll
at it.
each company
So
will determine that. That's for sure, right? If everybody's overworked with some things, it's going to be tough sometimes to get some time to fly the drone, or to learn the software or getting licensed. On our end, I don't care if it's a project engineer, an assistant superintendent. If somebody is motivated to learn and wants to use it, I'm all about it, and I'll teach you. I don't think there's any advanced skills to use photogrammetry. Um, I think it's more of will of the folks, right?
right.
You want to get your license. Do you want to study for it? Once you pass that first test, the rest is super easy.
It has been similar with LiDAR from research we've done with different teams.
Mhm.
And there's not really a lot of universities that even teach this.
Yeah.
So it kind of doesn't depend. It's not dependent on what the background is. It really is more a function of if the
Mhm.
individual is interested.
Yeah. One of my most successful pilots, that knows the most, that is super interested, is actually he was an intern for us. We decided he was like awesome, and we actually offered him a job. So he's going to school. We gave him a drone, and when we have a need, he goes and flies for us. And he doesn't even have a degree, and he's fantastic. He's very good at this.
Excellent. Well, I certainly appreciate the time you've provided with us here today. And we may have other questions that roll in, but I think we've addressed um, a lot of them. There is one I see is how you've mixed LiDAR with photogrammetry. And I think you,
I have not. I don't
okay,
have experience with lidar.
got it. Okay. Well, I certainly appreciate your time and look forward to maybe revisiting on this topic again next year. It's one that constantly updates and evolves.
Mhm.
And by any chance, we look forward to crossing paths with you again. And thank you very much, Carlos, again for your time.
No, thank you for inviting me. Hopefully, this was educational, at
Yes,
least.
You,
Luisa will hand it over to you.
yeah, thank you so much, Carlos.
Absolutely.
And for those interested in the 2022 LOD specification, it's out. It's available at Beamform Global/LOD. And these weekly webinars are continue on through October. And we have coming up next week, we're going to visiting BDC coordination from a general contractor perspective. And Carlos, again, thank you so much for your time. Thank you, everybody.
Absolutely.